Very good afternoon and a warm welcome to Adamas University. We'll be starting our program in a few minutes.
Just a minute, wait for a bit. Our resource person will be joining shortly.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Yes, sir, you are on mute.
করেছিস?
Good afternoon.
Yeah, good afternoon, sir. So can you hear me?
Who was host? Yes.
Yeah, sir, our resource person has already joined. Kasturi madam?
Joy.
Yeah,
Start the program.
can you make Sujoy our co-host so that he can share his
Sure,
screen?
Yeah, I'm doing.
Sujoy, can you hear me?
You are on mute, sir.
Yes, yes.
Yeah, now it is fine. Now
Okay.
it is fine.
Now I think okay. Okay.
Yeah. So we can now start our today's webinar. First, I like to welcome all of you who are present over here and who are being part with us with the YouTube channel. And this is our fourth endeavor with the flagship of future geographers and exploring the competencies which are required to be the future geographer. On that short note, I would like to welcome our Dean Sir, Jitendra Kumar Pandey Sir, and I would like to request him to put up the inaugural speech for this webinar. Sir, it's up to you now.
Thank you for unmuting me. So, Dr. Sujay, welcome to Adamas University's this Future Geographer series. And thank you for your time. I'm sure all our participants are going to get something that is related to their future and that will help them to set the goal for future. So, Department of Geography and the team Geography of Adamas University, they have started this very unique series. It's called Future Geographer, where we have been inviting people from industry, academia, well-known researchers who comes and share their views with all our students and participants. And that will actually help them to set the goal for the future. And that is something so important. If you do not know where to reach, then it is very difficult to reach. If you do not know what you want to become after learning geography in your life, then it is very difficult to be something that you want to be. So Future Geographer series is mainly, in a general sense, is helpful to set your goals, is helpful to understand what may be your career path, what may be your future path, and what is that you can learn and how you can contribute to the society. So well done, Team Geography. And I can see the mentor of School of Basic and Applied Science, Professor Sanjeev Bose. There are 121 participants right now, so it's a good number. And hope one day when Corona and pandemic things get normalized, we all will be sitting in a big hall and sharing our views that will have a different type of impact on each and everyone. So wish you all the best, and please go ahead as per your schedule. Dr. Rajiv, over to you.
Thank you, sir. Thank you very much. Thank you very much for your inaugural speech. Now, I would like to request our mentor, our professor of eminence, Sanjeev Ghosh sir, to give us a brief introduction about our university. Sir, it's now over to you, sir.
Sir, you need to just unmute yourself. I have asked one. Yes. Sir, once again, please. Yes, sir.
Yes. I was muted by you. Someone. I don't know.
I know, sir. Sorry, this is happening.
Okay. 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 So good afternoon to everybody. The Geography Department head and all the faculty members. Good afternoon to Professor Jitendra. Very good afternoon to you. And also to all the participants, students and other faculty members or students from the outside Adamas University. So I first congratulate head of the department as well as Kosturi as well as Rajiv for arranging this particular webinar, which is so useful in this pandemic situation. I was just in the meeting of farewell meeting of chemistry department. I just took leave for a few minutes, and I was talking there that I think the Adamas University, Rajiv told me to say something about Adamas. First thing I want to mention that during this pandemic period, please forgive me, the speaker. I think Adamas University, what university has done, no university or no institute has done so many classes, so many webinars, so many lectures, so many workshops. I can tell you that. All the participants outside Adamas University should know that due to the seriousness of our faculty members, due to their talents, due to their কি বলবো অফুরন্ত energy, due to their tremendous energy, I should say, all of them are so busy taking classes, preparing syllabuses, changing syllabus every time, doing the research at the same time, arranging so many lectures, so many seminars for the students as well as the faculty members. And I think this seminar also will help the students and the faculty members as well. So Rajiv told me to say something about Adamas University. This university was established in 2014 by an order of the West Bengal government, passed in the assembly. And then we started the session from 2015. So now it is 21, the 6th year. And right now we have about 3,500 students in, if you consider all the schools, all the departments. And to start with, we have the science department, very first school that we started, the School of Science and Life Science and engineering, and then it expanded to all types of possible areas of higher education. Like we have law department, we have engineering, obviously we have engineering department, we have department of management, we have department of economics, school of economics rather, we have school of education, and we have lots of other schools. And this year also I heard that School of Smart Agriculture is going to be open from this session. So Adamas University as a whole, and already we have planned for expanding to medical college. So with that, we have School of Pharmacy, very well established School of Pharmacy. And then we have the plan, because we have pharmacy school as well as so many people in life science and science. So we are almost ready to open the, or expand in the health science sector. That means we are planning to open medical science soon, very soon. That is the plan of our chairman, Professor Sumit Ray. And I was associated with him for a long time. And when he conceived the idea of having an university in Adamas Knowledge City, first thing he called me, and we prepared the whole thing, the plan, and the route, what should be the roadmap and things like that. And ultimately we established the university. And this university, from the very beginning, our purpose was not to just share, the acquired knowledge. That is the main thing, main vision of it, not to share, knowledge we already know, but the main purpose was to create knowledge. And to create knowledge means we have to emphasize on research. And we have been doing that from the very first day. And the first thing for this was the recruitment policy. So we recruited all the faculty members with lots of research background, so that all of them can, simultaneously perform teaching as well as research. And that's been going on for the last 6 years. And I'm very glad to say that many departments, including my department and School of Physics, Department of Physics, Department of Pharmacy, and all these departments, particularly life science departments, all of them have been able to acquire several grants from the funding agency like DST, and we are expanding our research as far as possible. And as I mentioned, that all the faculty members, they are very, I should say, talented, and they are trying their best to perform research, as well as to, syllabus is such in every department of every school is such that it is industry oriented as well as research oriented. And we give lots of hands-on training for every school. Particularly, I am very satisfied with the geography department. They're arranging so many things. And also outreach program we have, and geography department along with chemistry department, they have done a lot of things for this outreach program. Because this university is situated in Barasat, which is not a, is somewhat, not properly urban, is somewhat away from the Calcutta. And so we are trying to, develop our surrounding villages and all this. We meet people in the villages, try to solve their problems. And Rajiv and Kasturi and other members in the chemistry, they are doing their best to, to test water, first of all, and for lots of other activities like healthcare activities, literary activities. All the activities are done by this. So not only research, not only teaching, but this outreach program, university has taken a very, very strong measure for this. They have taken a very good step for this. So that is all about university. And today's lecture, I think, is on climate, no, Rajiv?
Yes, sir. Yes, sir.
It is on
Tracing the
climate.
past climate based on
Yeah.
geology, and
Just,
it also covers some of your part. Luminescence jetting
Okay.
will be there. He will
That
discuss.
will be fine. That will be fine. Okay, I'll try to listen, and if I get out from that particular meeting. Now, what is found? I found that only 2 days ago, the Nature brief. I got the news from the Nature journal. They have a brief. They send all the research going on the overall country, all the universe actually, and they send a message that regarding climatology, it was a goal that temperature should not rise beyond 1.5. Already 1.3. So if it goes, beyond certain beyond 1.3, or if it goes beyond 1.5, then the future is really very, very dark for us. They say that it will be, either very strong heat wave in some parts, and very cold wave, or flood, or rains, or even, cyclonic weather, and all these things will happen. And that is going to, in turn, affect our agriculture, our food production, and everything, including our health. So this climatology is a subject where every people is now joining to help improve the climate. In fact, in Scotland, I found that they have chosen this particular place, Scotland. Kasturi, you have been there, right? Kasturi,
I was in Stockholm.
you have been there, no? Scotland?
I was in Stockholm. Not
Stockholm.
Scotland.
No. Scotland, no?
None.
I don't know exactly. Okay. Scotland, they have chosen a particular area. They're trying to find a location where they are trying to set up a machine which can absorb carbon dioxide from the air. And then they want to put the carbon dioxide in somewhere in the sea or somewhere. So this kind of machine is already, they have planned and trying to set up in Scotland first. And then this company also will be, doing these things in other countries. So that how can artificially we can absorb carbon dioxide from the atmosphere, so that something to control the climate. That is one thing, a global warming or whatever. So I think today's seminar will be very helpful to all students and all faculty members and all participants, and we are all eager to listen to our speaker. Speaker named Sujoy, right?
Yeah.
Okay. So we are all glad that you are here, Sujoy, to help us, to help our faculty members and students to give your research output and your thoughts over the climate and over something else. So I hope this will be a nice afternoon for all of us. Thank you very much, Raji.
Thank you, sir. Thank you very much for your introduction to our university. Now, I'd like to request our head of the department, Madam Kasturi Mukherjee, Dr. Kasturi Mukherjee, to introduce our departments to the audience.
Thank you, Rajiv sir. A warm welcome, everyone. What sir has, Sanjeev sir and Dean sir has said, that after that, it's very little that I can say about the department. Already many things have been told. And I will not take much time. I will share my screen and show you one PPT about the different activities that we are doing in the department. So, allow me. Is my screen visible?
Yeah, it is visible.
Okay. Okay, we are now 9 faculty members in the department. The strength is 9. and we offer BSc, MSc Geography. Apart from that, we are planning to start, we are ready to start MSc Geoinformatics, and we have integrated MSc in Geography and Geoinformatics, PG Diploma in Geoinformatics and Geostatistics, that's a one-year course, and PhD program in Geography. So these are the 6 programs that we are offering presently in the, by the department. And what makes Adamas University a little different from other universities, what we feel, what we are trying is that apart from implementing the choice-based credit system in the UG level, we are also incorporating some science and mathematics subjects, which helps to bridge the gap between bridge the gap for the students who are coming from the humanities background. So it's a helpful, easy course for them to make them understand the statistical and cartographic concepts for the UG students. Then we have very good specializations in MSc, like apart from environment, geomorphology, regional planning, we have a very unique specialization called hydrometeorology, and we have remote sensing and GIS as well. Now, dissertation is compulsory as so also in other universities, but what we are planning, we are doing, we are putting lots of emphasis on the publication, publishing the dissertation in good Scopus Index journals or conference proceedings. Then we have field projects. Apart from the regular one big field, we are doing also small field trips. And in this pandemic situation, we are trying to do virtual field trips. Then we have many interactions with the foreign professors. We have good collaborations with them. And mostly in geography, without compromising the basic classical knowledge of geography, we are trying to incorporate the basic and the advanced tools and concepts of geoinformatics, because we believe that the employment opportunities are more when we are learning geoinformatics, the advanced concepts of programming in geoinformatics. We have compulsory internship. We used to send our students in various research institutes or private companies for internship, and we have placements as well in our university. So mostly through geoinformatics, we are focusing on these arenas for research, and our students are very much involved in research. Our MSc students, even the BSc final year students, are doing lots of research and presenting their research in various forums. I will show you some of the photographs. And what in master degree syllabus, not only the basic things of remote sensing and GIS, we are trying to impart the knowledge of big data in geography, computer programming, Python, mostly now focusing, and machine learning techniques in geography. So these are the few areas where students are from Adamas University are pursuing their careers at now after completing their BSc and MSc. And we, as I was saying, that we are collaborating with various universities for enhancing the scope of student exchange program, faculty exchange, and for collaborative research projects. We do not have out of the any special kind of lab, but we are expanding as we are new. We are trying to expand our laboratories. We now have 4 laboratories in our department. And we are encouraging a lot our students for participating in various co-curricular activities, in various conferences, seminars, and they are successfully presenting their research works. They have been awarded for best paper in various conferences. And in Adamas University, when we were doing it offline, we used to have workshops. And as Dean sir was saying, that definitely once the situation will be over, we will like to have all of you in our department, in our university. So these are few images that how it was before lockdown. And since the lockdown has started, we have moved online, as Sanjeev Ghosh sir was mentioning, that not a single day classes were called off. And these programs also, throughout the year, we have tried to keep these programs going. And we are doing this webinar series, Future Geographers. So it will be on for next 2-3 months, and we will be having various, we will be having the many renowned speakers with us. And definitely pandemic is not going to stop us from organizing this kind of interactive sessions. These are few pictures of our field visits, institute visits. Apart from field, we used to take our students for various institutes. Like we had a visit in River Research Institute. Then we went to ISAR for seeing the lab, for seeing the various type of research activities they are doing and how our students can get involved with them. We are trying to do that as well. Outreach program, yes, geographers has a special responsibility for maintaining their environment, the social environment as well as the physical environment. So we take it as our responsibility, and students are very much involved in various social activities, social outreach activities. With this, I stop my screen. I take down my screen and complete my presentation. Over to you, Rajat.
Thank you, madam, for your presentation and showing the scope of geography and how we are dealing with it. Now, I would like to put up our resource person in front of you. So it is Dr. Sujoy Bandyopadhyay, who will be talking on the topics of lessons from the past, exploring the quaternary activity, quaternary environment. Dr. Sujoy Bandyopadhyay is an assistant professor of geography at Kazi Nazrul University, which is located at Asansol, West Bengal. He has completed his PhD from the University of Bardhaman in 2019. As a major part of his doctoral research that was carried out, he collaborated with different organizations like Wadia Institute of Himalayan Geology. And there he conducted different experiments in quaternary fluvial sediments with optical stimulated luminescence dating. His research interests are quaternary fluvial records, earth surface processes, and applications of remote sensing and GIS in geomorphology. Sujoy Bandyopadhyay has received a number of grants and scholarships related to his research from national and international organizations, including German Federal Ministry of Education and Research, International Association of Geomorphologists, International Association of Sedimentologists, and Quaternary Research Association, UK. He has published internationally on these topics of his research. Now, I like to request Sujoy to come to the podium and put up his presentation. Sujoy, it's over to you now.
Thank you, Rajiv. Am I audible?
Yeah, absolutely.
Yeah. Respected here, Professor Jitendra Kumar Pandey, Dean School of Basic Science and Applied Sciences, Adamas University, Professor Sanjeev Ghosh, Professor of Eminence, Adamas University, and Head of the Department of Geography, Adamas University, other faculty members, Adamas University, students of the Adamas University, students and participants present here. Actually, firstly, I would like to thank Department of Geography, Adamas University, for inviting me to deliver actually a lecture on exploring quaternary environment. And it's nowadays it's the emerging discipline in science, interdisciplinary science. And let's start. I think I share my presentations. Yes.
In the middle section beside the chat. Yeah. Okay. Yeah, it is visible, Sujoy.
Visible?
Yeah.
Actually, today what I actually going to share to all of you, actually, it's lessons from the past, exploring the quaternary environment. It's actually what I have motivated from one book, actually published by David Montgomery in the year 2012, The Rocks Don't Lie. Actually, this book reflects the evidence of the Noah-style flood. and the geological evidences or sedimentary evidences of flood in the natural records. So from this book, I have motivated and I have started the research in the field of quaternary science. And what I have the little bit experience the last 10 years or 8 years, I'm sharing to you. And the first things, so why actually the quaternary period is very important to us. Actually, the important thing is within the geological period, the geological history of the Earth, it's 4.6 billion years. The quaternary period only includes the 2.58 million years of Earth history. But actually, in this period, during this period, whatever the variety of landscape we have seen within the Earth's surface, it is actually it's created during this period, which are the results of erosion and deposition. And the other things is very important. It's a climate change, and this period climatically most unstable period within the Earth history. See the map. It's actually climate reconstructed the map of the last glacial maxima during this period. We have heard about the term last glacial maxima because it is the last glacial period within the quaternary history during 18,000 years to 21,000 years ago. And if you look into this map during the LGM, most of the northern part of Greenland or North America or European part, it's covered by the ice sheets, and the temperature is very less during this last glacial maxima period. And also during this quaternary, there are several times the temperature actually increased and decreased like this. And we have seen nowadays warming already also happening, global warming. And the next thing is why quaternary studies is very important. It means the quaternary science because it promotes actually the long-term, the reconstruction of long-term records based on the sedimentary records, and also using the multi-proxy records, which actually shows the beyond the instrumental records. And this is very important nowadays. Why? Now, because of we have only 200 or 300 years records data. Like if we think about the climatic data, or if we think about the other kind of recorded data, historical data. Suppose if we look into the historical data or documental records, only we'll find more or less 700 years we have some flood records or like this. But beyond, if we look into the past, so in millennial time scale, so we have no records in the documentary evidence, or we have no records in instrumental part. So that's why in this context, this quaternary studies is very important, or quaternary science are very important. And it is a multidisciplinary science from various disciplines, like from geology, physical geography, biological sciences, archaeological sciences. A lot of researchers or scientists, they have worked or they are working from their discipline, and they contributed towards the quaternary science. And see the figure of the important quaternary belts in India, like Third Desert, Indo-Gangetic Plain, and Himalayas, where we will find the most of the quaternary evidences, based on the fluvial deposits or glacial deposits or other kind of deposits. Like in Third Desert, we will find the Aeolian deposits or like this. And the next thing is the period. Actually, this period it's very important, and there are several division of this 2.58 million years time scale. As per the International Union of Geological Sciences, they have ratified and they provided the time scale, the modern, most recent time scale is quaternary period. Actually, it's a part of Cenozoic era, we know, but it's all divided into two epochs. One is the Pleistocene, second one is Holocene. But later, actually, in 2018, the Holocene epoch, actually introduced by IUGS, the Holocene epoch, it's divided into three parts. One is the Greenlandian, second is Nordgrippian, and third is Meghalayan. Meghalayan stage is very important because we have heard about the recent introduction of the Meghalayan stage into the stratigraphic time scale, because it already recorded from the Meghalaya caves. We have heard about the Maumula cave in northeast India, and based on the speleothem cave deposits, they have established the onset of the drought conditions or dry conditions during the Meghalayan stage. This is the one of the important marker in the Holocene, because we know Holocene actually, that this Holocene epoch, we have heard this period actually witnesses warming phase, but it is also interrupted by such dry condition and also wet condition. So this Greenlandian, whatever if we look into the Greenlandian, this is the early Holocene phase. Greenlandian phase experienced by the warming phase, but after Greenlandian stage, during the North Dripian, slowly temperature decreases and the southwest monsoon weakens of the southwest monsoon. And during the Meghalayan, onset of the Meghalayan stage during the 4,200 years ago, the dry condition occurred in the Earth's climate. So that's why this is the important part of the Holocene epoch. And other one is the Pleistocene. Pleistocene epoch is it's an important part of Quaternary, because the two actually stage of the Pleistocene, which includes the lower and early Pleistocene, it's Galician and Calabrian. And the other two, actually the middle Pleistocene till in 2020, it recently introduced by IUGS. The name of the middle Pleistocene is Chibanian, and the other proposed name of the upper and late Pleistocene is nothing but a Taranthian. It's proposed, but not till included in the International Commission on Stratigraphy time scale. So this Calabrian phase of the Pleistocene, it's also very important in recent time scale, Quaternary time scale. Why? Now, because of during the Calabrian to Chibanian, this actually the boundary between the Calabrian and Chibanian during the 700,000 years ago, basically mostly we have heard about the geomagnetic chronology, one is the reversal time is known as a Martuama, and the other one is the Brunès period. We know normal polarity, we know reversal. In tectonics, we have heard about the magnetic polarity scale or like this. So the two time phase, one is the Martuama, it's the reversal, and the other one is the Brunès phase of this is the normal. Until date, it's Brunès. We are going through the Brunès phase of the magnetic normal polarity. So this time actually during this boundary 700 years ago, 700,000 years ago, Brunei Martuama period ended and Brunès started. Phase. So then that's why in this context, this Calabrian to this boundary is very important. And other things is the 700 million years ago, actually the human activities we have found the Paleolithic human activities. Later I will come the part of the human evidence of the Pleistocene during the Pleistocene. A lot of other evidences during the Quaternary period. Those who have worked and those who are working in this field. And other thing is several glacial and interglacial cycles we have found in Quaternary time period. What I actually mentioned, this Martuama to Brunès, this 780,000 years. This is the boundary between the Martuama and Brunès geomagnetic crons. And the other things, most of the Quaternary scientists, what they are facing till date, it's more the challenges, because the continental records, the records within the continent is not continuous, and these are the discrete records, right? But in marine sequence, if we look into the marine sediments, then there are continuous records. So the challenges, the important challenges is the correlation of the actually the continental records with the marine records, because this is very important thing here. How to correlate the continental records to marine records within the same time frame. So this is important challenges actually the quaternary scientists in the world, they are facing to correlate the marine records with the continental records, because from the marine records actually marine sediments, they have those who have worked, they have applied the oxygen isotope ratios like delta 18O and delta 18O. We know if the ratio is high, then it reflects the glacial phase, and if the values are less, then it means it reflects the warm phase. Delta 18O ratio is very important in this case, and based on the delta 18O ratios, they have identified a lot of time frame. It's called the marine isotopic stage or marine oxygen isotopic stage, and there are several marine isotopic stage records in the quaternary period. And we know the thing is that the odd number reflects the interglacial phase, and the even number reflects the glacial phase. It means if the Holocene, if we consider this is the Holocene present time period, it means it's MIS1, and then beyond this MIS2, MIS3, back to the past. Quaternary phase, MIS2 means glacial, then MIS3 means interglacial, like this. In that way, there are several marine isotopic stage we have found during the quaternary time scale. Based on the ice core and marine isotopes during the 900,000 years, we have found 1 to 22 stages, MI stages we have found, and here I have mentioned only the 7. The last interglacial to interglaciation, MI7, from MI7 to MI1, and MI7 is the interglaciation, 6 is glacial again. It means the even number reflects the glacial, and odd number interglacial, like this, because MIS1 means Holocene, the present day. So here the MIS5 is MIS2 and MIS5 is very important for the quaternary records, because MIS5 is the last interglacial is called, and in between the 130 to 80,000 years, in between this there are sea level was high than 4 to 6 meter high than present day, and like this. And during the MIS2 last interglacial, what I mentioned, last interglacial period, MIS2, during the MIS2, it means 18,000 years to 21,000 years. In between this, the sea level actually lower than the present day sea level, 100 meter lower. So that's why this, if we look into the sea level curve in the Ganga Brahmaputra Delta published by Anindya Sarkar et al. In 2009 in Quaternary Science Reviews, they have found the sea level curve, like during the MIS5, the sea level is high during the 125,000 years ago. But during 25,000 years, like in between 25 to 18, close to 18,000 years ago, during MIS2, the sea level is very lower than the present day. And this is MIS1 Holocene, the sea level transgression nowadays as occurring, marine transgression occur. So this is the important part of, again, the quaternary period. That's a good evidence from Italy. I have visited when in Sardinia Island. They have Vincenzo Pascuzzi group. They have found one good records of MIS5, and this is the close to the Mediterranean Sea, Sardinia Island, and they have found the beach, gravel beach records from these layers, and they have used the luminescence dating methods, like measuring the time. For measuring the time, they have used geochronological methods, and they have established the fact that during MIS5, the sea level was more 4 to 6 meter higher than the present, because we know when the sea level is high, basically beach environment will find beach environment, and when the sea level is actually lower than the present day, then we basically will find the dune fields or like this. So that's why this is the most important preserve units in Italy, Sardinia Island. It's a very good records during quaternary. And the other thing is during quaternary is the Henrich events during the MIS3. It's important events and also published by Pascuzzi et al. 2014. They have also found this kind of landscape changes or landscape response to climate, geomorphic response to climate change. They have found such kind of records in landscape, like when basically during the dry and cold events, high hills coast actually experienced by wide dune fields. Wide dune fields develop over the high hills coast. But when basically warm and humid events occur during the Henrich events like Danziger, Oisger events, during this phase, actually, they have found the alluvial fans, debris flow alluvial fans. So from this, actually, we can establish based on the landscape record. If we, as a geomorphological point of view, or as a student of physical geography, we can explore the landscape or landform anywhere in the world or anywhere within the Earth's surface, and we can unlock the past from the changes in the landscape. So that's why in this case, so quaternary records is very important, because we based on this record we can establish the past events or past. We can narrate the history of the past environment, whether it's a geomorphological environment or climatic environments or other kind of environments, other kind of like human activities or like this. The other things during quaternary, why it's very important, because humans and culture evolved during the quaternary, because we know there are several publications from recently from the archaeological sciences from India, and they have published one paper in Science and one Nature, and they have found from Tamil Nadu Atirampakkam sites, they have found the presence of early Pleistocene Acheulean hominins in South India, like during the 1.5 million years ago. It means the human activities, and they have used actually the early Acheulean hominins use the Paleolithic tools like hand axes or like this. And also they in Nature paper, they establish the out of Africa models, because previously we always like this. In Africa, we can only found the evidence of the human activities or like this. But till now, the researchers from archaeological science, they have established the fact that out of Africa models, and in India, they have also found the human activities, like during the during 1.5 million years ago, during the 50,000 or 40,000 years ago, like this. The other things from other publications, important publication from West Bengal, Basak et al., they just published two papers. Recently, they published one paper in Geological Society of London in 2021, and they have also published one paper in Current Science. They have found the records from Purulia district of human activities like microlithic industries near Ajodhya Hill. It means 35 to 21 or close to 40 to 20,000 years ago, they have found the records of the microlithic industries. It means human activities. So this is the important part. We can unlock. We can, based on the natural archives, we can unlock the records of the past. See the table. It's a very important publications by Misra et al. In Science Reviews in 2019. They from the lacustrine records, because there are several type of archives from where you can reconstruct the past, like fluvial archives, like archaeological artifacts, like other kind of proxy records, or lacustrine sediments, or marine sediments, or other sediments, glacial sediments, or aeolian sediments. This is one of the important publication. Based on the lacustrine records, they just have narrated the history of the last 11,000 years climatic records in this paper. And from the Younger Dryas to the present day, they have shown in their paper the several time phase of warm and cold phase. Like if you look into the last 2.5 thousand years history of the climate, you will find like Roman warm period from 2.5 thousand years to 1.6. Then again one short cool period interval like Dark Ages cold period. So, and again medieval climate anomaly, and we have heard the again little ice age in between 1400 to 1800 Anno Domini, Common Era. and the present warming. So there are several climatic intervals within the Holocene interglacial phase. So it means we are looking for the high resolution records, right? So because of we have only high resolution instrumental, like only 1 or 200 years records of instrument high resolution data. But if we look into the millennial history, 1,000-year history, the records are not continuous. These are discrete and not high resolution. That's why scientists or researchers are looking for the high resolution records of climatic changes or like this. The other publication, good publication recently by Dutt et al. In Current Science, it's in Himalaya, basically the disparity in summer monsoon precipitation from when basically transition from North Grippian to Megalayan, what I have already mentioned. From the Greenlandian, when basically we move from Greenlandian towards Megalayan, then precipitation definitely, the southwest monsoon weakens more and more. And during the Megalayan transition phase onset of the drought, actually, it's a responsible factors for the collapse of such civilizations or different other kind of changes in landscape. And this is the important publication by Sarkar et al. In Nature Scientific Report, and they have established from the oxygen isotope records during the Meghalayan. Actually, the Harappa civilization declines due to the onset of the drought during the Meghalayan phase, of what I mentioned previously. And the thing is that the next is the reconstructing the past. Actually, I have discussed already how we reconstruct the past, or what we can use the archives, like riverine or fluvial archives, or other kind of proxy like biological proxy or geological or geochemical proxy we can use for establishing the quaternary any kind of quaternary events. And see the figure, that's a very important figure by which you can, you will find from the high elevated areas to lower part, you will find there are different type of archives like glacial archives or lacustrine archives or riverine dunes, playas, marine deposits, and the other important thing is the cave deposits, paleothems. Based on, you can reconstruct the past definitely and narrate the history. So basically, as a student of geography and physical geography, and also student of researcher of geomorphology, the important archives we have, it's a fluvial archives, and this is very much readily archives to us to reconstruct the past. Why? Now, because of we know rivers are the most active and sensitive elements of the landscape, where basically we found more, if any kind of changes occurs in the environment, it propagates through the channels or rivers, riverine landscapes. And if we consider the system, if we consider through the sedimentary system, we can consider here is the alluvial system. And alluvial system, in alluvial system, it includes one is the fluvial environment, and second one is the overbank environment. And the channel, and we in channel environment will find the channel deposits, like mostly sandy deposits, and in overbank deposits mostly we will find the fine facies or sealed muddy facies. So, and other thing is important, alluvial system actually occur in various, a wide range of terrestrial tectonic settings, and it definitely is the recorders of different allogenic factors such as climate, such as tectonics or sea level change. And also it definitely shows the intrinsic variations or adjustment in channel planforms. If we use the fluvial archives, then we can remember the classical lens balance model, because it's very important model by which any kind of changes in sediment load or sediment size or slope or discharge determine whether the fluvial system will aggregate or whether the fluvial system will incise, because we know there are two types of forces in fluvial system: driving and resisting force. Driving force means if we consider steam power, it's a function of discharge and slope. If the discharge is high, then it means the driving steam power is more, and definitely the driving force is higher than the resisting force. It means basically in size, the fluvial system in size, and other things. If the resisting force, the sediment load is high, it means the equilibrium of a river system actually disrupted by this this kind of controlling factors like climate, tectonics, and nowadays we can also consider human activities also important controlling factors nowadays in a river system. Then the other thing is, if we look into the Fluvial Archives, so first we consider the alluvial succession. The succession, it means the sequence of the alluvial, sedimentary system. So we will find like sandy deposits, or we'll find in a vertical section we'll find definitely sandy layers, or we'll find the mud layers. Mud layers means silt or clay. We'll find, so it means if it is a sandy layers, it means it reflects the channel environment. And if we find the muddy layers in alluvial succession, definitely reflects the it's a overbank, it means a floodplain environment. So suppose if we drill towards deeper enter into the deeper part, so in vertical section we may find alternation of sandy layers or muddy layers like this. So we can infer that from this sequence there may be some kind of channel switching within this region, because if channel shifted towards the other channel shifted, then definitely where basically sandy face is found, then it is overlain by the muddy environment. It means the overbank deposit. So that's why alluvial succession in this context, actually alluvial succession is very important, and we can study the alluvial succession of a particular fluvial environment. And there are several terms associated with succession like lamination, stratification. So now if we look into any bed or layers or lamina of less than 2 centimeter, so we consider first whether sedimentary texture or structure. If sedimentary texture, it means it reflects the size, sedimentary grain size. It means it from clay to gravels or boulder. If we consider the sedimentary structure, it means the stratification. Stratification means whether we find the horizontal lamination or the cross bedding. It means cross bedding, cross lamination like this. This is the good example. See the figure. This is the good example of the cross laminated layer. And this is the good example of the horizontal laminated layers. So the other thing is in fluvial sequence, you will find, if it is a fluvial sequence, so you will find the upward fining, say in sedimentary texture, like at the bottom, you will find the coarse grain size sediment, and at the top, you'll find the fine size sediment. But if we look into the deltaic sequence, then we'll find the upward coarsening sequence. Like at the top, you'll find the sandy layers, and at the bottom, you'll find the mudstone. This is the good example of the alluvial succession of deltaic environment or fluvial environment. Then the other thing is the time, measuring time, because it's very important. Like, because rates of this process, because if we understand the physical process, any fluvial process or like this, so we can estimate the rate, or we definitely measure the rates of this process. So for this, we can apply the different type of geochronological methods. There are several quaternary geochronological methods like this. In this slide, you see the slides, like there are several type of geochronological methods, from isotopic to correlated methods. Like if we want to get the numerical age, you can use the isotopic dating methods like cosmogenic radionuclide datings, or radiogenic dating like luminescence, or you can also use the relative age, like whether it's much older or younger. So you can use the any kind of tephrochronology or archaeological correlation method. And the other thing, in this slide you'll find like which method is suitable for in which range. Like if you want to date the 300,000 years sediment, so you can use luminescence, but definitely that there are two types of you can use also quartz-based luminescence, or you can use the feldspar-based luminescence. If you use feldspar-based luminescence IRSL, so you can date it the 300,000 year sediments. But if you use the quartz-based luminescence optic OSL methods, then it's very difficult to date beyond 80,000 years sediments. And if you want to date the 100,000 years sediments, then it is impossible to apply the carbon 14 methods, 14C methods, because we know the half-life, basically the law of radioactive disintegration, and we know the half-life of the carbon is very less among all isotopes, only the 5,000 years, close to 5,700 years. So it's very difficult to get the carbons beyond 40,000 years, older than the 40,000 year sediments. So that's why the most important thing, what kind of geochronological methods, what kind of quaternary dating methods we can use in what type of sediments. So that's very important. So first you have to choose the dating methods, so which methods actually suitable for your work. The next thing is the fluvial, actually the records of the climate change. We know the most readily, records, we know what we actually use the term flood. It's a mostly readily evidence of the climate, because flood is nothing but imprints of the warming phase. So that's why we know that there are two types of flood. We know one is the outburst flood, which is the most of the largest flood within the Earth is the outburst flood, we know, and caused by the sudden release of stored water. And it is also termed by Baker 2002, it's mega floods. Most of the outburst flood is mega floods, and which actually the discharge, peak discharge is higher than the 1 million cubic meter per second. So this is very important. And the O'Connor and Costa published in 2004 one paper. It's a late Pleistocene mesolar floods. We have heard this, late Pleistocene outburst flood like Bonneville floods, like mesolar floods, like Altai floods. So see the figure, see the figure here. It is the boulder transported by the mesolar floods, and this kind of landscape actually termed as a scabland by Baker. So that's why it is also the imprints of the climate change during the quaternary phase. And there are several type of outburst flood due to different type, like why this kind of outburst flood happened in the past, because due to the landslide blockage, due to the glacier surges, or any kind of dam burst, or any natural closed basins filled with water, such as tectonic basins. Due to this, such a outburst flood happened. I know we have heard about this flood, Glacial Lake outburst flood also in Himalaya. And see the figure by O'Connor et al. In 2013 is most of the floods, what I mentioned, like Bonneville, Misola, Altai, these are all mega floods, and 10 to the power 6 million, greater than the million cubic meter per second, the discharge higher than. So that's why these Bonneville, Altai, and Misola flood, and see the Misola flood, the one of the important, largest flood in the world. It's close to 10 to the power 8. It means 10 to the close to billion cubic meter per second. So that's one of the largest flood during the late Pleistocene. Based on the natural archives, they have established the flood records. And the other floods, it's a meteorological floods. We know these are mostly occurred due to the high rainfall, and these are the combination of the flood type due to the rainfall and due to the snow melt. And see, most of the rivers which is close to tropical areas, these are the flood actually occurred due to the rainfall, and the other beyond the tropical areas, the floods occurred due to the snow melt or other, like glacial lake outburst or other kind of factors. Due to this, the flood happened. And the Paleo flood records is very important for narrate the history, because nature, we know, because if we use 100 years or 200 years instrumental data, so and predict some kind of, like nowadays people, researchers or a lot of workers, they have used, or they are working in modeling, and they use only 100 years data or 50 years data, and they apply, and they just get model some kind of predicted values or like this. I think the most important thing is the reliability, and the most important thing is the certainty. Is there any certainty within this value? So most important, because if we predict the future, like if you predict the 500 years, or if you look into the future, so the first thing is we can use the longer term data, because and it only provided by the nature, because the instrumental records only very few, we have the few instrumental data. So that's why if we look into the natural records, so definitely it provides us the reliable guidance, definitely. Because sometimes people are the most of the quaternary scientists, they are facing the challenges, like like those who are planners or policymakers. They mentioned, it is academic exercise, or it is definitely useful for society. We don't know. People are those who are those who are policymakers or planners. They have used this kind of term, like this is like nothing but academic exercise, the reconstruction of the past. Those who are working with the past records, or those who are those who are working with quaternary science. So this is the most important thing now we can consider here, because if we reconstruct the past, or if we reconstruct the longer term data or longer term records, then we can provide the guidance to the society. So that's most important thing for us as a student of geography or physical geography. We can contribute something to society for reconstructing the past, or for reconstructing the longer term records, because they are, as a student of physical, like climate science, or a student of geomorphology, we can based on the different type of geomorphic records, we can reconstruct, or we can do these things. So that's why Paleo flood records, it is very important nowadays. And there are different type of methods by which people, researchers, they have identified some Paleo flood sites or Paleo flood sediments. That's it's not very easy to identify the Paleo flood sediments. Whether if it is sand, it's not Paleo flood due to the flood. The sandy deposits, or if we find in alluvial succession the sands or pore size sediments, it's not due to the flood. All the time. So that's a very important thing we can consider. So the most important thing is the identification, how to identify this kind of successions by which we can establish this is flood deposits, or this is any the deposits by normal flow. And the other important publications by Panda et al. In 2020, they have worked in actually northeast Himalaya near Sangpo Gorge, where actually Namche Barwa Massif. And based on the sedimentary sequences, a study of the sedimentary sequences, and based on the geochemical study, they have identified two types of flood here, actually, based on the sequence. Like one type where actually see the map. Basically, the river, the Sangpo Brahmaputra river here, this is where you will find the higher Himalayan crystalline sequence, and here you will find the Tethyan sequences. And they have found the sediment deposits of two types of sediment deposits. The deposits which actually transported from the Tethyan sequences, and the deposits which from the close to the Namche Barwa. higher Himalayan sequence. And based on this, they have identified two types of floods. One like glacial lake outburst flood, and the other thing is flood induced from the rainfall during strong monsoon season. And based on the luminescence chronology, they have identified at least 8 large flood in between 7 and 1,000 years. So it means it is some something indication of some warming phase or some kind of climatic shift in between this time phase. And the other important publication by Bourgoin in Quaternary Science Reviews 2020, the records of mega floods near Namche Massif, evidence of so we can use this kind of archives and we can infer the climate change or climate shift in Quaternary period. And this is the important sites, past global changes, very flood working group of the past global changes, where we will find the different type of data, flood data, and they have gathered the data worldwide. And if you have interest, you can explore from this site and you will find a lot of data here. And Pages Flood Working Group, they have they call for contribution in the framework of the working group and identification of 381 published historical and paleo flood records, at least the last 100 years. Then I have some little bit experience from the Ganga Plains. I'm sharing to you. I have found from the fluvial sequence a little bit, signatures of climate or signatures of the river channel shifting or channel other kind of river behaviors in fluvial sediments. So this is the regional map of the Ganga Plains, where there are two part of the Ganga Plain. One is the northern part of Lower Ganga Plain and the southern part of Lower Ganga Plain. And the Rar Plains is a part of the southern part of Lower Ganga Plain, where we'll find a lot of western tributaries of the Bhagirathi River, like Muiraki, Ajay, Damodar, Darakeshwar, Kangshabati. It's a very important place where we'll find the quaternary sediments, very thick sediments. At least near that town Bardhaman, you will find 1 kilometer sediments, 1,000 meters. The basement depth is 1,000 meters. So that's why the most important region where we'll find the quaternary sediments and for quaternary study. If we look into the rivers, if we look into the past, so in 100 years, during the 100 years, there are several times flood happened. So that's why I have explored the sediments. Like see the first photograph during the 1978, actually Hinglo Dam breached due to the flood, and it is captured by Neogi, Medula Neogi in 1984. Publications, and the other photograph actually I have captured during 2015, the same areas of the Hinglo Dam. It is also breached during the 2000 flood again. And the two photographs, it's very important. During 1978 flood, the railway bridge in between Gushkora and Vedia, it also breached due to the 1978 flood. And the other 2008, and I have captured the photographs close to Mongolkot due to 2007 floods. It is due to the embankment breaching, actually the sand incursion happened in the agriculture field. So that's why the rivers actually experienced by a lot of large floods during the recent century. So that's why this deposits, the fluvial deposits in this area, it's very important for quaternary study. So that's why I have explored a lot of sites within these areas, like the first important sites which I have actually found near Niligarh, and the other one is the Polasdanga, where Hinglo rivers meet with Ajay River, and the other one is Panduk. Panduk is very important archaeological place, we know. And the other one, other sites, which is near Borjora, close to Damodar River, actually. It's the important sites where we have found the Pleistocene records, very earliest dates of the Lower Ganga Plains. And the next actually, but we have actually from the boreholes in the Panduk, near Panduk, we just conducted the field study, and we have 3 boreholes, two near Panduk and 1 near Navagram, close to the mouth of the Ajay rivers. So these 3 sequences, it's very important, because here already I have mentioned that in alluvial succession, if we find like the alternation of sand and mud, that it means there may be some switching of the channel environment and the floodplain environment. So here in these 3 sequences of the flood, this stratigraphic succession, we have found the alternation of mud and also sand, and different type of, definitely the sandy texture. So the texture of the sand is different, like coarse sand, like and I have here we have used the feces analysis, like based on the texture and based on the color, based on the other things, like this is the borehole data. So that's why sedimentary structure is to find the sedimentary structure is very difficult. So that's why we have not mentioned any sedimentary texture structure here, like stratifications or like this. So that's why here we only mentioned the texture, whether it's a coarse sand or fine sand or like this, and we have dated the sediments based on the luminescence chronology, optically stimulated luminescence dating, and it's an important dating. It's an important quaternary geochronology, and based on the quartz minerals, you can date the sediments, fluvial sediments or aeolian sediments or coastal sediments, where we find the quartz or feldspar minerals. So based on the quartz based dating, we have found the dates in between 2.4 thousand years to 1.3 thousand years here, and it's very interesting. Close to 2.4 thousand years, we have found the channel records. It means the rivers, major rivers, close to Panduk. But nowadays, from Panduk, actually, it's 2.5 meter away from Panduk, 2.5 meter. Like in previous maps, like the area here, we just conducted the survey, borehole survey, and a drill course, and based on the sludging method. And from here, the modern day rivers actually away from 2.5 kilometer away from the Panduk. So that's why, but during the before 2.4 thousand years ago, we have found here the channel records. So this is very important, because in archaeological, in archaeology, a lot of archaeologists, they have established the fact that near the Panduraja Dibi, actually close to the Ajay River, and what I actually we drew the Panduk site actually close to the Panduraja Dibi, these sites. So that's why we can establish the fact that definitely at 2.4 thousand years ago, there was a major channel. Maybe it's Ajay River or other rivers, Ajay-like rivers, river. So we have found this, and again, we have found the muddy environment after 2.4 thousand years. After 2.4 thousand years, we have found the muddy environment, and again and after 2,000 years, we have found the channel environments. And similar, but the similar other boreholes, we have found the muddy. It means floodplain environment. So this Panduk. This borehole actually very much close to this borehole. So that's why this is the channel. When this is the channel environment, the similar at the similar depth, we have found the muddy environment. It means the floodplain environment. So that's why we definitely we inferred the fact that during this time there was a channels and there was a floodplain environment close to the Panduraja Dibi. And the other two sections, it's very important records from the from the Niligad and Palasdanga sections, and where we this is the exposed sections. That's why we have mentioned the sedimentary structures, where we mentioned like horizontal stratifications or cross stratifications. And see the figure near Niligad, we have dated the sedimentary sequence by luminescence dating, and we have found in between the dates in between the 800 years to 200 years, and we have found such flood deposits here, and we have found flood deposits here. During 800 years ago, like where actually before the Little Ice Age, we can if we look into the different other records, other climatic records, we will find the warming phase before the Little Ice Age. So that's why during this warming phase, during 800 years ago, we have found the flood records. And again, after the Little Ice Age, it means in between the 18th century and 19th century, we'll find such kind of flood records also in sedimentary layers. And also there are several from the historical some documents. Definitely we have also found some flood records in between 1700 to 1900, 1890 or like this. So that's why we can correlate these records with the documentary evidence or historical records. So this is very interesting thing we can do. If we can correlate the natural records with the documentary evidence, or if we have some kind of records in documents or published records, or and we can narrate the history of the past. And the other, so based on the data, based on the isotopic records, or like this, we can prepare. We have prepared the composite diagrams like Kathayat et al. In 2017 paper based on the Saya cave records, Delta 18, like this. So the group, they have divided the climatic phase into Roman warm, Dark Age, cool. Medieval warming or Little Ice Age, like this. So based on this, we can date it. What if you look into the dates? These are the date range. So during the warming phase, this yellowish bar, it reflects the warming phase, and the other greenish light green, this bar actually reflects the cooling phase. So these records correlated, these dates actually correlated with the warming phase. It means because of this kind of dates, actually we have dated the sandy deposits. So that's why sandy deposit, it means it reflects some higher, because of higher flow, higher energy environment. So that's why this we can correlate this kind of fluvial evidences for fluvial any kind of record with the established or published climatic history. And the other also, I have correlated, or we have correlated the other flood records with our records. Like in similar time, there are 14 large flood events in the Upper Ganga catchment, which is published by Vasan et al. In Upper Ganga catchment. And during the Roman warm period, already published by Goswami et al. In 2019 and Panda et al. 2020, they have already published. There are several floods in Kaveri basin and other northeast Himalaya. And before the Roman warm, actually in Ganga Plains, there are records of dry climate. Ghosh et al., Ruby Ghosh et al. Published in 2013, and based on their records, this reflects the dry condition before the Roman warming phase. And this slide actually, it's a very interesting, it's under preparation. This is the first dated evidence of the less Pleistocene fluvial activity from lower Ganga Plains. And what actually till date, we are actually preparing the all other calculation part. So that's why there are other dating samples already we are calculating this. And the two dates actually we have found, one is the 46,000 years and one is 71,000 years. And this is the one of the earliest dates from the lower Ganga plains during Quaternary. And what we actually found here, that during the 71,000 years ago, we found, this is close to Borjora, near Damodar River Valley, and around Damodar River Valley. And we found during 1,000 years ago, we found the large sand body. Like it means it close to, if we look into the this composite diagram, this is like this. This is the end of the MIS5. MIS5 means the last interglacial. So that's why this is close to this reflects the warming phase, where actually found the large sand body in the lower Ganga plains, and the other day, like 46,000 years, it's before the last glacial maxima will again, because we have seen in my previous we have seen in previous slides the similar kind of records in Sardinia Island. They have found, like during the Henrich events, the warm and cold phase like this happened during the past. So that's why during the 46,000 years ago, we again we have found here the large sand body here. So we can correlate this kind of records with the published isotopic records or temperature records or sea level, and then we can correlate with this isotope study or sea level study. Like this kind of deposits actually happen during when the sea level is high. Aggradation occurs, and again during the MIS3 when sea level is little bit high, so then again we'll find the sand body. And the other part of the Holocene records, which is during the MIS1. So that's why based on this we can finally we can conclude that based on this Fluvial archives, we can get some idea about the past environment, whether it's a geomorphic environment or climatic environment or the kind of environment. But based on several type of archives, not only Fluvial archives, there are definitely other like lacustrine records, like speleothem records or other records. Those who have worked, they have published the papers based on the records. So we can study this kind of archives, and we can correlate with the past climate, and we can map the history. So that's why in this this is the emerging field. So people already working a lot of in the world and in India also, a lot of papers published, and good papers published in several good journals, and different part of Himalaya, like from north to south in Himalaya, in Ganga Brahmaputra Delta, in western part of India, and also in southern part of India, like Kaveri rivers, like western part of like west coast of India. So finally, I'm sharing to you such some organization. You can, if you have interest, you can join, because I have I have shared to you. It's my little bit experience about what is science, because I am continuously learning. This is very it's not very easy to learn. This is the interdisciplinary science. So that's why those who have interest, they can join this the International Union for Quaternary Research. It's one of the important organizations in the world, and they organize in a 4 years interval. They organize a Congress, INQUA Congress, and I'm very lucky. I have attended one INQUA Congress in 2015 in Japan, and the last year, 2019, I missed the opportunity, the Congress, INQUA Congress in Dublin. And you can also explore the site of if you have interest. And the other in 2019, there are other important association in India, Association of Quaternary Researchers. If you have interest, you can join. It's a very important organizations in India. Those who are working with in quaternary science in Indian subcontinent. And other is Quaternary Research Association in UK. Those who are here, those students, you can join QRA, and you can get the several, they have the grants. They provide some grants for research. I have also achieved some little bit from the grant from QRA. for my research. So that's why if you have interest, then you can join for your research. You can get the grant. And the other important organization, Fluvial Archives group. It's important. Those who have interest in geomorphology or fluvial geomorphology, they can join the Fluvial Archives group, and they organize several webinars or seminars or conferences like this. And the other important organization, International Association of Sedimentologists. If you have interest, you can also join, because they also provide some grants for researchers. Those who have interest working with sediments, whether fluvial or other sediments, they can join. And also they introduced one interactive platform. It's SED Online. You can also join SED Online. It's an interactive platform, and they organize webinar interval in several times. So that's why if you have interest, you can join. And other is the past global pages, the organization. It's a core project of the global sustainability science program of Future Earth, which is previously it's a part of the IGBP program. You can also visit the pages site, and you can get some overview, very past environment. They have published, they are publishing one newsletter or certain publications. So that's why you can explore the pages website. And the other things, it's important in July, the month of July, one important meeting, virtual meeting. We are very lucky in this year, in 14 to 15 July, international actually conference on fluvial sedimentology. Those who have interest, they can attend. It's a free for all. They can join the conference on fluvial sedimentology in virtual platform. And these are some important journals of quantity science. Like you can explore these journals and get some papers, important papers like Journal of Quantity Science, Quantity International, Quantity Science Reviews of Quantity Research, Boreas of Quantity Geochronology. These are very important journals of quantity science, and these are the books. I'm sharing these books like Loem Walker, these important books, reconstructing quaternary environments. The other books, Bell and Walker, Late Quaternary Environmental Change, and the other part, it's a quaternary dating method. It's a very good books by Mike Walker. And the other two books I am highlighting here, it's a very good books. There's the Geology of Fluvial Deposits by Eddie Meal, and the other one is Depositional Sedimentary Environments by Rene Singh. You can explore this book and other books by Anderson and Gurdy, Global Environments through the Quaternary. The book is very important. And I'm sharing to you, these are the labs, important labs, where you can visit and for dating the sediments. These are the labs, the important several labs. Nowadays there are other labs beyond, but these are the 7 important labs, like IUAC, where we'll find the AMS lab, Accelerated Mass Spectrometry, or Wadi Institute of Himalayan Geology, definitely is very famous for luminescence dating and other datings also. And Birbal Sahani Institute of Paleo Sciences, also famous for luminescence dates, carbon dating. And ISER Kolkata, it's very close to us. They have luminescence lab, Monosar there. And Institute of Physics Bhubaneswar, a CSIR lab in GRI, and PRL. PRL also, we know the physical research lab. It's a very important, one of the best lab in India. So that's all. Finally, thanks to all. Thank you very much.
Thank you, Sujoy, for your very illustrative, elaborative, and explanatory presentation. I hope all the attendees have got the light that is coming out from your study. In the meanwhile, we have got some questions.
Sure. Can I stop the sharing?
Yeah, Sujoy, you can. The name is not written over, but it is Galaxy A8 Plus. Asked that what is OSL age stand for?
Optically stimulated luminescence dating. There are several types of mostly three types actually we can use. One is the thermoluminescence TL dating. Second one is OSL, optically stimulated luminescence, and the other one is the IRSL, infrared luminescence. Based on the IRSL is based on feldspar, and the other one OSL is based on the quartz meter.
He also asks that is there any type of evidence that the flood mentioned in historical age, such as Murgeon age? Is there any evidence of Murgeon age floods that can be detected with this sort of techniques?
What actually I
say for example, Murgeon age. Historically, there is a Mourjo dynasty.
Mourjo. Yes, I think there are several documents, historical documents. Maybe if we explore the historical archives, maybe we can will find the historical records of floods. Definitely, because in nowadays there are three types of flood. Like one is the instrumental floods, second one is the historical floods, and third one is the paleo floods, right? So what I'm discussed here, it's all about paleo floods. It's beyond the documentary evidence or instrumental evidence. So historical evidence, definitely nowadays people are exploring the flood memory approach or markers or any documentary evidence or like this. So if we explore, then we can definitely will find the evidence of flood during the historical period based on the documents, definitely.
I also request Sumon Chatterjee, if you just find any question in the YouTube section, just put up to Sujoy. Put it up there to Sujoy so that he can answer. Shumon. In the chat box, I can see another question, Sujoy. How detection of paleo channels could help exploring the mega floods or paleo floods? Paleo channel.
Actually, paleo channels are definitely sometimes in several papers already those who have published, they have found some paleo flood records or paleo flood sites near paleo channels or like this. But paleo channels identification is very difficult because people are actually they have used, those who are actually using remote sensing approach, they have used satellite image or like this. But beyond actually sometimes the fluvial system actually respond very slow, not very fast. Large rivers, the case of large rivers is different, but some rivers which actually, like in case of raw rivers, the response of the raw rivers is not very fast, it's very slow. So that's why in this case the sedimentary evidence is very important for establishing the channel migration or channel shifting, right? So from the satellite image, it's very difficult to identify the shifting of the channels. Definitely, in case of Ganga or in case of Brahmaputra, definitely the case is different. But in case of small rivers, it's very difficult to identify whether the channels actually, I don't know. But from the sediment, that's why people are using the sedimentary evidence or sedimentary records. So in the world, so that's why in this case, they have used the records of the sedimentary sequence, and they have found some flood records or other kind of channel shifting or other things.
Okay. Shumon.
Yes. Actually, I was muted, therefore I was unable to ask any questions. Anyway, So thank you, first of all, thank you very much, Dr. Bandyopadhyay, for such an informative and engaging discussion. And I hope the discussion has attracted the attention of fellow geographers and they have benefited in one way or another. As the theme of the webinar implies, we are exploring some of the unexplored areas where the geographers can work. And as a geographer, we all know that the scope of this subject is quite vast and unlike any other subject. And it is expanding every day, actually. So there are some questions already has been asked. There is
I've seen one question, very interesting. From chat box. I have seen one question by Jinia Saha. The history regarding the decline of the Harappa civilization is still unknown. It's not still unknown. You have, if you have, it's not my paper, but a lot of scientists, they have published a lot of papers. You should go through the papers. You will find the reason of Harappa decline. They have used the oxygen isotopes. They have used the other kind of scientific methods, and they have established the fact that drought is the important responsible factors for the Harappa decline. You should go through the paper. It's not definitely it's not my paper, but they have established already. It's not still unknown, because science already continuously advanced. So that's why you should go through this paper. There are several papers on Harappa civilization, and there are a lot of papers published on Saraswati River or like this.
Okay. I myself have one question. So you also mentioned about isotopic methods and for the reconstruction.
Yes.
And so my question is there any application of stable isotopes, particularly in this types of research?
Yes. This oxygen isotope, actually, these are the stable isotope, definitely.
Okay.
Stable oxygen, carbon, not 14C definitely, but carbon, other isotopes.
Okay, thank you. I think that is all for the question and answer.
And last question, a very interesting part is that Shanhita Pal has asked, is the study of paleoclimate help us to study the future trend of climate? So we were talking about a lot about climate change. And this question basically focus absolutely right to the point.
Definitely. If you have some sort of cycles of the past climate, at what time actually what we have, definitely the high resolution data what we have, it's only for 200 years, last 200 years or 250 years. So if you have the paleoclimatic records, the longer term records, so definitely we can get the reliable guidance what will be the future, definitely. Because that's why we are exploring, that's why the researchers from quaternary science, they are exploring the past environment, not only the climate, definitely the other behaviors, like whether any kind of natural hazards, because flood is not new, right? Earthquake is not new, right? So these are all tsunami, these are all happened in the past. Paleo tsunami, because a lot of researchers, they have worked and published the papers on paleo tsunami records or paleo seismic evidence or other kind of so that's why nowadays the paleo science, already the past global, what I have mentioned in my slide, the organization, important organization, the past global change, just the organization actually highlights the paleo science, but actually the importance of the paleo science, the role of paleo science. It's not actually the previously I have mentioned, it's not academic exercise. Basically the planners or actually the others, they are thinking about this kind of past records or the looking into the pipes, and nothing but exercise, academic exercise. It's not academic exercise.
Okay. Apart from this question, some of you are asking about the PPT. So answering to that question.
One questions I have seen, I think from Genius again, Anthropocene is claimed to be another new period in Quaternary. after Holocene, if you could throw some light on it. I have no any idea about, because I definitely I have used previously in other talk, or I am using, but Anthropocene till date, Anthropocene is not included in the International Commission on Stratigraphic Time Scale. So that's why it's very difficult to say about the Anthropocene. Definitely there is some kind of people are nowadays researchers, they are working the human induced human activities definitely enhance the the hazards, amplified the natural this kind of events, the natural extreme events definitely. But till date, till it's very difficult to say whether Anthropocene is it's nothing but a proposal, or it's we can use Anthropocene as a permanent time frame. It's very difficult. So that's why I have no comments about this.
Shuja, just shed some light on what are the competencies that is required to explore the arena of quaternary geomorphology as a geographer.
Actually, we can add. Actually, it's a very interesting. We can in geomorphology. If you have, I'm talking about. I'm just here. I'm mentioning the part of the syllabus. If you in syllabus in geomorphology, if you add some sort of quaternary geomorphology like the quaternary time frame, or the records all about the archives of the past. Reconstruction of the past, for reconstructing the past, all archives, if you include, or other thing is very important. It's
I'm talking about the student competencies, that a student, if he has some basic idea about, say for example, some physics, or some sort of statistical part, some sort of chemistry oriented study. So that part I am talking about.
That part I'm not getting your.
Yeah, I'm talking about as a student of humanities. Can a student of geography explore this arena? Like
yes, definitely. Why not? Why not? Because from the secondary level, actually, we have learned all things, all about the landforms, the climate from second. So that's why we can explore. Because in other beyond actually the abroad, in UK or in US universities, the geography department, they just the student geography student, they learn the quaternary science as a part of their syllabus. So that's why it's no problem. We can also the student of geography, they can explore the field of paleoclimate, or the field of quaternary science, or quaternary geomorphology, whatever. Because quaternary science is not it's very vast. Okay. From because it includes the part of biological science, it includes the part of chemical science, it includes the part of physical science, includes geological science, and also physical geography. So that's why and also archaeological science, definitely. So most of that, it's the interdisciplinary science, so that's why in various branches so they explored, they are exploring, and they contributed towards the quaternary science. So we can definitely explore from a geography background. I'm sure they will do these things.
Okay, thank you, Shujoy. Thank you very much for your presentation. It's been enlightening event for us, and all the participants, I hope enjoyed it thoroughly. Now I would like to request our friend Tuhin Vadra, our department colleague, to put up vote of thanks for the event.
Hello. Thank you, Dr. Rajiv Shakar, for giving me this opportunity. And first of all, on the behalf of the Department of Geography, I would like to express my sincere gratitude to the Honorable Speaker, Dr. Sujoy Bandyopadhyay, for sparing his valuable time, and also for his valuable lecture on this quaternary environment. I hope all the participants have learned a lot from his lecture and will enrich their knowledge in the field of quaternary environment. I'd also like to thank all the participants for making the event a successful one. I'd like to express my sincere gratitude to Honorable Chancellor Sir and Vice Chancellor Sir for giving us the opportunity to organize the webinar. I am thankful to Pro Vice Chancellor Sir and Dean Sir, School of Basic and Applied Sciences, Professor Dr. Jitendra Kumar Pandey, for his encouragement and guidance. My sincere gratitude to Professor Sanjeev Ghosh, Emeritus Professor, Adamas University, for his inspiration and motivation. Special thanks to the Office of Dean School of Basic and Applied Sciences, IT Cell and Media Cell of the University for their support. I would like to express my heartiest thanks to the moderator of the webinar, Dr. Rajiv Sarkar, and the coordinator of the webinar, Mr. Suman Chatterjee, and all other faculty and staff members of the Department of Geography, starting from the head, Dr. Kusturi Mukherjee, Dr. Onu Rai, Dr. Supratim Kormakar, Mrs. Manushi Devnath, and Ms. Monisha Boral, in making the webinar a successful one. I'd like to remind you all that the Department of Geography is going to organize the next webinar on the next Saturday, that is 3rd July 2021, and the theme of the webinar is mitigation suggestives on storm and water surges in the Sundarban in the light of human pursuit in the area. Hope to see you all again in the upcoming event. We have already reached the end of this program, and I'd like to request Dr. Rajiv Sarkar to end this program.
Thank you, Tuin. Thank you for putting up the vote of thanks. And in continuation of this, we would like to draw your kind attention to our next event, which will be conducted on 3rd of July. Again, another webinar under the Future Geographers flagship, that is mitigation suggestives on the storm and water surge in the Sundarbans in the light of human pursuit in the sea. Apart from that, we have a very big event which is coming on 12th July to 19th July. This is a faculty development program and summer school on climate change analysis using R and cloud computation with R, Google Earth Engine, and Python QGIS. So in that summer school, you will be analyzing all the tools and techniques about climate change scenario. And I welcome you all on behalf of the Department of Geography to participate in this two events. Now, in this point, I draw your, I would like to thank you for your support to conduct this webinar. Thank you all. Hope to see you soon in our next handover. Thank you.
Thank you, Rajiv.
Thank you.
Thank you all faculties, Department of Geography, Adamas University.
Thank you.
Thank you, sir.
Thank you. Bye-bye.
Bye-bye.